We've talked about covalent bonds being double or triple before when we talked about diatomic gases. Oxygen in the air shares its 2 free electrons with another oxygen atom, so that there are 4 electrons in the bond between the 2 oxygen atoms, and that gives us a double bond. Nitrogen has 3 free electrons, and nitrogen in the air is N2, so those 3 free electrons are shared with the other nitrogen atom to make a triple bond. So a triple bond has 6 electrons in it. A double bond has 4 electrons in it, 2 from each atom. Okay? Triple bond, 3 from each atom. Double bond, 2 from each atom. And the unshared pairs in nitrogen and oxygen sit around the outside of the whole structure and don't do anything apart from affect intermolecular forces. So carbon can do the same thing. It can make a bond by sharing one of its free electrons with the other carbon atom, and we get a single bond. It can share 2 of its free electrons in the unshared bonding electrons in its valence shell with the other carbon atom, and the other carbon atom will share 2 as well. And we get a double bond where there are 4 electrons from each carbon in the bond. And it can also share 3 electrons from each atom in the bond, and we can get a triple bond in the between the 2 carbon atoms. And you might think that you could go all the way and get 4 electrons shared between the 2 carbon atoms, but as far as I know, that doesn't happen, but there may be physical conditions in which it happens. We're not going to worry about it. What we're going to think about is single bonds, double bonds, triple bonds. Think of each finger as an electron. My hands are atoms. That's essentially what you think of. So 1 electron, single bond. 2 electrons, double bond. 4 electrons in total. 3 electrons, triple bond. So let's draw out our single bond structure for carbon. And what happens here is I'm just going to draw the electrons for this carbon atom in red. And I'm going to draw it around the atom like that. Okay? And I'm going to draw the electrons for the second carbon atom as blue. And what we can see is that there are 2 electrons in the bond, and there are 3 electrons in each atom that are able to make bonds with other atoms. And so we generally represent the structure like that. A single line represents a single bond. A single bond represents 2 electrons. All right. Let's look at a double bond. Okay, so in this case, the 2 electrons are shared from this atom, and then the other 2 electrons distribute themselves evenly. And the same thing applies here. 2 electrons are shared from this atom in the bond, and the other 2 electrons are shared spaced evenly around the outside. So this is now a double bond. There are 4 electrons involved, 2 from each atom. So let's draw that in. 1, 2, and then the other bonds are stuck around the outside as evenly spaced as they can be. Now, the interesting thing about double bonds is they're non-rotatable, and this becomes important in some structures later on in our learning. But you can't rotate this carbon. So this, whatever's up here and whatever's up here, is stuck in place. So, for example, if I've got a certain thing here and another thing here, they are always going to be opposite each other. They can't rotate. Whereas if I have a chlorine here and a bromine here, this carbon can rotate and bring the chlorine over beside the bromine. So that's an interesting point, and it's something that becomes important later on in organic chemistry. Those compounds will have slightly different properties. So let's do our triple bond. And we have 1, 2, 3 electrons shared in the bond, and only 1 stuck around the outside, because you've only got 4 electrons in the valence shell of a carbon atom, and we get 1 on the outside. So what we get here is we get a triple bond. This is similar to the nitrogen bond, except that the carbons can bond to something else on the outside. So we have 6 electrons triple bond, 4 electrons double bond, 2 electrons single bond. 1 electron from each atom makes the 2 single bond. 2 electrons from each atom double bond. 3 electrons from each atom triple bond.